Hello everyone, welcome back to my YouTube channel. Today we are going to talk about a very interesting question, which is Dijkstra's algorithm. So basically, what is Dijkstra's algorithm? Let me explain you this question first. So basically, in this question, we will be given an undirected graph. So the weighted graph with vertices v, and which numbered from 0 to v minus 1, and edges each has e edges, and basically we will be given a source vector like given in this example. And for this question, the source is 2, and we have to find out what is the minimum distance that will be required to travel from source to each of the nodes. For what basically what is the shortest path to go to each vertex using this source. This is a very important question. This question can come in various form, like you will be given nodes as in like various cities, and you have to find out uh, uh, like you will be also given uh, the the money that it takes for you to fly from one city to another city, and you have to find out what is the minimum how you can reach from source city to any city using such that it cost you the minimum amount. So this question can come in various interviews as well. If you're preparing for quant interviews or software engineering interviews, this question is a very important one. So we have to find out basically the shortest path that will take from source to any vertex. For example, in this example case, we have to we are the source is given as 2 for, so this what is the minimum distance that will be required to go from 2 to 0 or 2 to 1 is like 2 for 2 to 0. The minimum distance will be uh, first one would be 2 to 0 is 6, but we can go from 2 to 1, then 1 to 0, which is 3 plus 1 4. Similarly, for 2 to 1 we have the minimum distance as 3, and for 2 to 2 is because this is the source, so the distance will be 0. This is another example. For this example, the source is given as 0. We have to find out the minimum distance to each of the nodes. As I said, like the graph can be directed or not, or undirected both. If it's an undirected graph, we will be first converting it into directed graph so that it would be easier to solve after that. So for this question, we have been given a 0 as a source node, and for 0 to 1, the minimum distance will be 4. For 0 to 2, the minimum distance will be 8, which is directly going from 0 to 8. For 0 to 3, it is 10, which is 8 plus 2, 10. And for 0 to 4, we have we will go for 0 to 1 and then 1 to 4, which is 10 as well. So we have to solve this question. However, we are going to solve this question. We are going to solve this question by implementing the Dijkstra's algorithm. This is the implementation, but I will explain this implementation step by step. But before that, to understand Dijkstra's algorithm, let straight dive into the solution and the explanation. So let's take a question example in which we have been given both directed and undirected no, edges both. As you can see, like for in this case, the source node is 1, and for node 1 to 4, it's undirected graph, undirected edge, and others are edges. Other edges are directed. 1 to 4 is undirected, and also 3 to 5 is also undirected. The rest of them are directed. So let's discuss this algorithm using this question, this example, so that it would be easier for you to understand the logic and the concept behind the solution. So when we are starting from node 1, uh, which is initial case, what we are going to do, we are going to initialize all of the other nodes as infinity or int max, whatever we are going to take. And then we are going to consider an algorithm in which we are going to check the current distance plus the edge distance that we have right now, and we are going to minimize for each of the node. Like if current distance is 10, and let's if current distance is 10 and we are going to have to go to 2, and 10 plus this edge, this is 50. If it's less than int max or whatever the current value for that node is, then we are going to minimize for each of the node. And this is what we are going to do here. So we started with node 1. From node 1, we can go to node 2, node 3, and node 4. So for initial vertex, the this table is basically showing what is the distance that that we can take to move from node, the source node, to each of the nodes, and we are going to uh, update this table by going step by step to each of the nodes. Yeah. So for 1 to 2, it's 50, 2 to 3 is 45, and 2 to 4, as you can see, like we can go from 1 to 2 in 50, 1 to 3 in 45, which is less than infinity. So we are going to infinity or int max, whatever we have, but whatever value we have initialized. But for explanation purpose, I'm taking it as infinite. And for 1 to 4, we have 10. So this is our initial distance. Now we will move on to the minimum of these values, which is 10. How we are going to find out the minimum? So for that, in the code, we have initialized a priority queue heap, basically. So that is a minimum heap. So that the top position of that priority queue is going to give us the minimum distance that we have till now. So right now we are going to update the current distance plus the distance till 2, or distance till each node, and we are going to save that updated value inside a priority queue. So as we can see, like the distance from 1 to 4 is 10, which is minimum. So we are going to move on to 4 and initialize it as our current source. So we have moved to 4. Now we are going to check from 4 each of the node whether this value is minimum, or how can we modify this value or not. So from 4 we can go to 5, we can move to 1. Okay, so 2 is going to remain the same, which is 50 as it is. 3 is also going to remain the same, which is 45 as it is. As we have going from 4, so 4 is also going to remain as it is. Now we can move from 4 to 5 with 15. So initial value of 4 was 10 plus 15. It's going to give us 25. Now we are going to check whether this 25 is less than previous value, which was infinite, or not. Obviously, it's less, so we are going to update our table to 25, and we cannot go to 6, so we are going to keep it as it is. Also, we can go from 4 to 1, but we are not going to check it because we already have visited node 1 with least value, which is 0. So there is no point of checking it. So what we are doing, we are in the priority queue, we are also are going to check. We are going to in the priority queue, we are going to take the minimum values and the source as well, so that we will make sure we are not visiting the same node again and again. Now, from uh, after this, as 10 is already visited, so we are not going to uh, take it. Now we are going to find the minimum of the remaining values, which is 50, 45, 25, and infinity, which is 25. So we are from 4, we are going to move to 25th node, which is 25, as this is minimum of the rest of the node. From 5, we are again going to check which of the node we can visit. As you can see, like from 5 we can go to 2, we can, or we can go to 3. So we can go to 2. The current value of 5 is 25. So 25 plus 20, which is 45. So this is less than 50. So we are going to update our table. As we can see, we can reach to with a value less than 55. So we are going to update it as 45. Now from 5 to 3, we can get 25 plus 35, which is 60, which is more. So we are not going to update this value. Now, as we already visited 4, so we are going to skip this, and 5 is our current source, so we are going to skip this as well. We cannot reach 5, so this is our final table value after 5. Now, from this, the minimum value is 2 and 3 and 6 are only left. So out of 2, 3, and 6, the minimum value is 2 and 3 both, which is 45. So we are going to move to 2. So from 2, now we will check it again where we can go. We can go from 2, we can go to 3 only. So we are for 3, the minimum value is 45 plus 20, so which is more than 45. So we are going to not change it. We are not going to change it, and rest we are going to keep as it is. So none of the value got updated, but we visited 2. So only 3 and 6 are left. So out of 3 and 6, we can see like 3 is the minimum. So from 3, we can go to 5 only. So, but 5 is already visited, so we are going to skip this as well. Now from 6, we can go to 5 only, but 5 is already visited, so we can skip this part as well. So all of the table value is going to remain as it is. So this is how we are going to find the minimum shortest path from each of the node, starting from the source node. Now let's move on to the solution. Also, like you can see here, the updated code is the updated values as well. As you can see, after visiting each of the node, I am putting it as underlined so that we are not visiting it again. How I'm going to implement this in the code? Let's talk about that. We are going to implement it in the code by taking a priority queue, and we are going to pop that value once it's visited. That's why I have put this value as underline, so that you will have an understanding which values we are not visiting again and again. Like here, once 4 is visited, I pop that value out of the queue, priority queue, so that from after in this iterations, we are not iterating this again. Like we are not visiting that node again. So here, after 4 is visited, as you can see, like I underline 4, now 5 is visited, I underline the value of 5. Basically, underlining means I am popping out it from the priority queue. Let's see the code. The code is straightforward, but let's talk about like the code step by step. Only there is a little bit of modification, or which is not orthodox type of code. Is when I'm initializing the graph, I haven't used like I haven't created a 2D uh, vector basically and initialize the value of each of the weight. The reason behind this is it will create our we it will create an initial vector very large, because as you can see, like each node is not connected to all of them, so there is no point of like creating too many values with 0 edges, you know what I mean. So in this way, we are just going for from each of the node, we are just going to initialize only those edges only which are connected to that node. So what I did, first of all, these edges I 1 0 1 2 basically represent here the initial node, then final node, and then the weight of that edge. The so U, V, and W are basically the U basically representing the initial node, V representing final node, and W representing the weight. Now, for this question, this is an undirected graph. So we are going to convert it into directed graph by just changing one thing. which is we are going to push that from u. We are going to take u as our initial vector and going to push uh, this v and w as a vector. So what I have done, first of all, let's understand how I have initialized the vector. Is I have created a 3D vector. Then that 3D vector has v nodes, obviously the number of node that we have initially. So v node, and for each of the node, I am pushing the value v comma w inside each of the node. For the starting node, for any node, I am pushing the node and the weight. Like that, I'm initializing the vector, this graph basically. So as you can see, like this, I'm taking u as initial node, and I'm pushing v comma w, v basically representing the final node and weight. So how we are going to access that value is adj is our vector 3D vector name. So adj u is the starting node. Then whatever is our size of the that 2D vector, then it's going to have two values. Basically, the first value is our final uh, final node, and the second value is our weight. So that's how we are initialized this. This is just to optimize our code and take less space as possible for our code. Now, what other thing that we have initialized is, first of all, distance array and the minimum heap. This distance array is basically going to store our table that I showed, that we discussed, that we were discussing here, this table. So this distance vector is basically going to store uh, whatever the minimum distance that we have for each of the node. So what we have done initialize this distance vector with number of nodes and initialize each of the values as int max, like infinity, as we discussed during the example. And we have initialized the source value as 0 for the obvious reason, because we are in the source and we can reach source with 0 distance by covering 0 distance. Now we have also initialized a minimum heap. This minimum heap is basically to find out the minimum distance from node source node to each of the node, like to each of the node which is connected. So for that, one thing that we should note here, I have initialized priority queue as a vector, and that vector is basically storing two values. The first values is the node weight, basically the node weight, that what is the distance for, because this is what we have to minimize, right? The weight required from a source to a source node to other node, this has to be minimum. So this is value, and the source value, like from where we are reaching that value, like from where that node is from the source. So right now I initialize this value as 0 comma source, because we are in the source, and that value is 0, because the weight value to reach 0 is from the source to source is 0. Now this is our main, this is step 3, and this is our main loop. We are going to iterate this loop until we have until the priority queue value is empty. So for that, I initialize a vector, the top value, which is so going to store the top position of the priority queue, priority queue, which is minimum heap. So it's going to give us the minimum final node and the weight of that node in a form of vector. And we are going to pop that value from the priority queue. The reason being, because that value is already reached. So we are not going to, we have to pop it out, and we are not going to check that value again. So current distance is going to be, uh, the first value is going to store the distance basically, so which is top 0, and int u basically representing the node, the current node from where we have to start now, which is the minimum. Because after each iteration, what we were doing, like we were finding out the weight, the distance from the current node for each of the node, and then we are going to move to the minimum node, minimum distance that is required to reach each node. As we discussed here in the example, we started from 1, and then we move on to 4. The reason being because the 4 has the minimum weight. So minimum distance required to cover that node. So basically, I have initialized a priority minimum heap queue, priority queue. So that is storing the minimum value and the node. So u is the node, and this is the current distance. So we are going to move on to 4 basically in the example, which is u, and the distance required to reach 4 from the previous node. So this is what this part of the code does. Now we, after moving to the current node, we are going to check all the nodes which are connected to our current node, and we are going to find out the minimum distance. We are going to update our distance vector this table, and we are going to check if the minimum distance from current plus weight is less than our current distance, then we are going to update it, or otherwise we are going to skip that. So we have initialized a for loop. This for loop is basically checking all the nodes which are connected to our current node, which is initialized from I equal to 0 to I less than adju dot size. So this size is basically representing the number of nodes which are connected to our source node. And v and weight, like I already explained you initially, how we initialize this our graph basically. So the number of values that we have for each of the node, as we have, is going to represent the number of nodes that are connected. And for each of the uh, nodes, we have a 2D vector basically, in which first is representing the node which is connected, and the second is representing the weight for each of the node. So v and weight are basically adju, which is first value, and the second value we have stored. Now we are going to check if the current distance plus the weight is less than the distance or not. If it's less, then we are going to update our distance table. Otherwise, we are going to skip it. And if we are going to update it, then we are going to push that value inside our priority queue. Like here, we are checking if the current distance is less than, current distance plus weight is less than the distance that we have initially. Of course, like during the initial phase, we initialized all of the values as int max, so all of the values are going to get updated. So the distance value is going to be, we are going to update our distance value for that node, which is current distance plus weight. The same thing that we have done here, initialize everything as infinity, and then from 0 to 50, if it's less than infinity, then we initialize that value as 50. Then 0 to 45 is less than infinity, then we initialize that value as 45. Similarly from 4 as well, which is 0 plus 10, which is 10, which is less than infinity. So we've updated, and the rest that are not connected, we skip that. So this is what we have done, the distance vector. And then also we updated our priority, that we pushed that value inside our priority queue to check whether to find out the minimum out of all of them. This basically represent that first of all we push the value of distance, comma, the v value, which is the node, and we are going to iterate this value until the priority queue is not empty. And finally, we are going to return the distance vector, which is going to store the minimum distance from the source node to each of the node. That's all. If you found this video helpful, don't forget to like, subscribe, and comment your questions or thoughts inside the comment box. I'll see you in the next video. Thank you.